flow and pressure. But interestingly, only 5% of the airflow that comes out of the fan is actually provided by the impeller down the bottom. So we're pushing 5% of the airflow up this tube, and it then comes out of this annulus around here, which is about a 1 millimeter slot. And it goes over this aerofoil section, which is like an aeroplane wing. As the air, as it goes over the top curvature on the wing, accelerates, because it has to catch up with the air that's on straight underneath it. And that acceleration causes negative pressure, which causes the wing to lift. Now we're creating negative pressure, it's going to be quite we're creating negative pressure which sucks air in from behind as it goes over this aerofoil section which runs all the way around here. And then there's an outward cone here of about 16 degrees, and that too creates negative pressure from behind. So you've got two great forces of negative pressure or suction sucking air from behind. And then there's a third effect, that there's a cylinder of air coming out of here. And that cylinder of fast-moving air creates what's called viscous shearing, which is a nice expression, where the air that's here gets pulled into the air that's this cylinder that's going very fast. So you start off with only 5% of the airflow, then multiply it 18 times for free, if you like, as it comes out of here. So that's the principle of how it works. I've been told not to go into long scientific explanation as to why, if I move this ambient air, which is quite warm, over you, you feel cool. Not a quick explanation. Am I allowed to get a very quick one? What happens is that you have an aura of steam around you when you're hot, and you therefore can't let the heat out of you. So a fan blows that aura away. That's aura's quite a nice word. It's sweaty. And then blowing the air over your skin evaporates the moisture on your skin, and that's a refrigerant. So it's like when you get out of a swimming pool or a bath, you feel cold. That's because the water in your body is evaporating, and that's a refrigerant effect. So that's why a fan actually works, although it's very low amount of wattage, it's only 40 watts compared with 50 times that very emission. So it's very environmental and rather pleasant way to keep cool. Now, the benefit of using this technology is that you're not chopping the air. A fan with blades chops the airflow, and so you're buffeted. Well, not literally, but you can feel it. It's rather unpleasant. Whereas this is, there's nothing to chop the air. It's just a very smooth breeze. It's obviously easy to clean and very safe. And this one has the air coming up this tube, and the tube is telescopic, so wherever you push it, it stays. You've got to adjust the clamp, undo a clamp, and then readjust the clamp. And we've got a tensator spring in there, which is a constant force spring. So wherever you put it, the spring supports it and it stays there. And similarly, we've angled it with the velvet washers, so whatever angle you put it at, it stays. And the motor's down in the base. Normally on a fan like this, the big heavy motor would be here, which makes it inherently unstable, and also makes locking this at an angle very difficult. So we've got the motor down there, the thing is very stable, and it's controlled remotely by a remote controller, which stays there magnetically. It oscillates, as you can see. And with the tower fan, we've made a running track shape, that's perfectly obvious. And the technology works perfectly well as a running track. I think that's it. I think I've bored you, so I'll stop talking, move over to have a drink. So thank you very much for coming.